Java 9 JCP. And Heather Vankira runs the JCP now. So she's actually the of the Java community process. How about this guy? Okay, so we were talking about voting on Java 9. So the London Java community member one of the voting members is Martin Verburg. He started Adopt OpenJDK, and he also is one of the folks on the Java community process. And this is Yolande Poyer. So she runs the Java Twitter handle. So if you ever see tweets from Java, that's actually coming from Yolande. Here's a photo from the Java 1 community keynote last year. We had a Star Wars theme. So, you know, Yolande, who else do you recognize? This is Heather here. Who's hiding here? You guys must know him. Yes, very good. So that's James Gosling. He dressed up as Darth Coder, and he had a big red nose on him like a Duke as his costume. So he was wearing a Darth Vader costume with a big red nose on it. So lots of fun. This is Daniel, who runs DevOps for Kids. He did a demonstration with the Now robots. This was a drone which Michael Hoffer built. I have a picture of him later. Entirely built using Java and a Java constructive geometry library. And another good way to engage is conferences and unconferences. This is the JFocus Speaker Unconference, which happened recently in Storhogna. So northern Sweden. We did a trip for an unconference after the JFocus event. This is Crete, so the JCrete conference, which is actually happening 2 weeks from now. So this is a community unconference. This year they opened up the registration quite a bit. So there was over 150 people attending. So I think they're going to overrun the island. But basically it's morning unconference sessions with speakers and other folks. And then afternoon excursions. So in the afternoon you can go to the beach, go hiking, visit the oldest olive tree in the world, and then chat about geeky things like big data and Java versions and microservices and all the wonderful things which we talk about when we should actually be having fun. Here's a community panel in Japan, bike rides around the world. This is Michael Hoffer, the guy who built the drone earlier. He's working on a Formlabs printer. This is a stereolithographic printer. So it prints out of a vat of liquid plastic, and it uses a laser to cure it. So it cures it and draws, makes the object from the bottom up, and then pulls it out of the liquid, and then you clean it with alcohol to get some of the resin off and finish off the print. Here's Vinicius Singer from Brazil and a bunch of his IoT projects. He built his own IoT surfboard, which is his own custom embedded device, and then has a bunch of cool projects which you can do with that, including an alcohol sensor. So we might need that later. See who's had too much to drink. This is the smallest member of the Java community. So Trisha Gee, who is a member of the London Java community, she now lives in Spain. And she was at Java 1, and she brought her youngest one with her. And you can see in the background here is the Hearing Nest project, which I'll talk about a little bit later. But it was a community art sculpture which we made. User group forums, interviews. So I do a bunch of different interviews under the Night Hacking brand, and we've opened this up as a community brand now. So if anybody would like to stream to the Night Hacking Twitter handle or the YouTube channel, and they have like good equipment, then you're welcome to use it to broadcast Java-related videos and content. But if you follow the Twitter handle at Night Hacking or go to the nighthacking.com site, you can see a bunch of the videos and content. A little more about Kids Workshop. This is Arun Gupta, who runs the US DevOps for Kids chapter. And I do a bunch of workshops with him. And we're also, Arun and I are currently working on the Java 1 for Kids schedule. So if anyone's interested in presenting kids workshops at Java 1, you can still submit talks for that. Just let me know. Okay, and then who follows the Java Twitter handle? Okay, well, not too many. How about Facebook? Okay, so this is a good way to find out the latest news about the Java community. So I'd recommend Twitter is probably better if you had to pick one. So follow the Java Twitter handle, and then you'll get notified whenever cool stuff happens, whenever there's updates on Java 9, or there's different things happening in the Java community. And also, we post a bunch of different videos on the Java YouTube channel. So about a month from now, the JVM Language Summit's happening in Santa Clara, California. And that's for all the language creators like Mark Reinhold, Brian Getz, Stuart Marks, Alex Buckley, all of the John Rose, all of the people who are behind the JVM will be presenting about the Java internals for each other. Usually they get other folks like from the community like Charlie Nutter who created JRuby, some of the other authors of different JVM languages to present as well. And it's really good technical content that you can't find anywhere else. It's really hard to attend the JVM Language Summit because it's a very small set of folks that can accommodate, usually only about 50. So we're going to live stream and record all of the talks from the JVM Language Summit. And you can follow the Twitter handle, or you'll find them on the Java YouTube channel later on. Okay, so let's switch topics. I'm going to talk a little bit about Raspberry Pi and Java. And I need your help with this. So we have a line follower demonstration, which will hopefully work. And I brought some tools to make a line. So the way this works is the robot can reliably sense white tape and black tape. So we're going to create a track for it to follow with white tape first for the base, and then black tape down the center, so he can follow the black line down the center. And we'll just, pick somewhere in the room to make a large track. So who wants to give this a try? I need 3 volunteers. Okay, 1, 2, 3 in the back. Come on up. Okay, so from experience, I'll give you some hints on stuff which works. So he can follow smooth curves, like if you angle it, but not too sharp. So make it a little wide, and he can follow 45-degree turns. So if you angle 45 degrees, it will follow around the 45 degrees, but not sharper. And you can make the track cross itself as well if you're careful. So sometimes a cross will work. No, well, a cross at 90 degrees will work pretty much all the time. If you cross at a funky angle, he might choose a random direction to go. But if you get a 90-degree turn, it should work. And I would say go up the stairs, but he's not going to make it up the stairs. he might make it down, but not up. But have fun. Maybe for the purposes of the camera, it would be better if you did it on that side. That way they can just tilt the camera down and then see the robot. Scissors? Yeah, so they don't let me take sharp objects on the plane. Does anyone have like a pocket knife or something? Oh yeah, perfect. Yeah. Okay, so we have our 4th volunteer. You can help out if you want as well. Okay, while these guys are working on the track, I'm going to talk a little bit about the technology for running Java on the Raspberry Pi. So a bunch of folks said they have Raspberry Pis, but who's run Java on their Raspberry Pi. Oh, very good. Excellent. Who was it? Who was it who said they had a lot of Raspberry Pis? I think you did, but no Java. Okay. Hopefully we can fix that and get Java running on some of your Raspberry Pis. So for everyone who doesn't have a Raspberry Pi, they're very inexpensive. 35 euros, about. This is a collector's item. This is the original Raspberry Pi B. So you can tell by the fact it has one USB port. The current models have 4 USB ports. They have a quad-core processor, HDMI out. This composite out's been taken off, but it's integrated into the audio plug, so you can get composite out using the 3-prong audio plug. And the most important thing on these is actually the GPIO pins here for hooking up different devices to it. So it works just like a computer. You can run a Linux operating system on it. You can power it off any 5-volt power source like a cell phone charger, and it uses an SD card as the hard drive. But the GPIO pins allow you to hook up to different sensors. Like you can hook up to scales, anything which supports serial, any I2C sensors. So for example, you can do accelerometers, proximity sensors, temperature sensors. You can also hook up to simple on-off devices, control relays. It really lets you interact with the physical world. So you can go from, code that you write to actually controlling simple mechanical devices, which is cool. And it's very, very easy to get started on the Raspberry Pi. So it's created by the Raspberry Pi Foundation in the UK. And the setup process for the Raspberry Pi with their Noobs installer is as simple as just copying some files to an SD card, booting it up, and then going through some prompts on a attached monitor to choose your operating system and language and stuff like that. So it's designed to be easy enough, even kids can get started and can use the Raspberry Pi effectively, which is a big departure from traditional embedded development. I mean, if you did embedded development 5 or 10 years ago, you would easily spend a couple weeks just serial tipping into a device, installing funky drivers, dealing with bugs on the development boards. So the Raspberry Pi Foundation got rid of all those eccentricities of doing embedded development, which really made it difficult to do as a hobby. And we're going to specifically run Java 9 on the Raspberry Pi. So I've reconfigured this demo to run Java 9. And just for some of the highlights of Java 9, probably the biggest one is the new module system. So I know that I couldn't fully understand everything in French, but I know he was talking about the module system a bit in the introduction. But what they've done essentially is fix the class path. So historically, the only way you have to control what your dependencies are is by adding or removing things from the class path. The module system actually lets you give a proper structured definition of what your program depends upon in a list of modules. And you can substitute, different modules at runtime. You can do different things to actually create a more robust system for your application. And they've also applied this to the JDK, so they've modularized the entire JDK, which lets you subset it and choose just a portion of the JDK that you want to compile or that you want to link against your program. So it's a huge change for the Java runtime. This has been over 10 years in the making. I remember, must have been like a decade ago at Devox. Mark Reinhold announced that modularity was going to be part of Java 7 at the time, I believe. So it didn't quite make Java 7, but or Java 8 for that matter. But it's really great to see that it's finally coming out, and it creates a very solid foundation and gets the Java platform up to the same place that a lot of other more recent languages started with, since they have a module system baked in. So some of the JEPs. JEP stands for Java Enhancement Proposal. So this is how the individual components get suggested and approved. So some example JEPs are, there's a JEP for locating and loading classes on the basically modular runtime images. So this is an improved jar format. It's more time and space efficient than using zip files, and allows you to extend it in the future. The JLink, the new Java linker, allows you to create a program. This happens after the compile step, but before runtime. It allows you to link together an executable. So it'll figure out all the dependencies between the modules for your application, pull that together into a single executable, and then allows you to deploy that. So if you're on a space-constrained device, like a small embedded platform, you don't have to have a full JRE installed on there. You can just have your program plus all the dependencies that it needs. For example, nowadays you almost never use the Corba module, but at the same time it's part of the Java standard, so every JRE has to have a Corba implementation baked into it. So this allows you to subset exactly what your application needs and then deploy to small devices. I'll show an example of JShell a little bit later. So JShell is a command line REPL for running Java applications. A bunch of different languages, including Haskell, JavaScript, Ruby, etc., already have REPLs built in. It makes it very easy especially when you're learning a language, to try things on the command line. You can try some of the new streaming libraries or some of the built-in functions in Java quite easily using JShell. And it's a nice way to test your programs or test small parts of your program before you actually deploy it, or if you're not using a full IDE. And the last feature I think is relevant for embedded is the new HTTP2 support. So the HTTP2 support allows you to do persistent connections. This is a new web standard. Typically people use Raspberry Pis headless. So I have some examples of Raspberry Pis with user interfaces, since it has a UI connect or display connection attached to it. But if you have a headless Raspberry Pi, often you'll want to run a web server and then use either REST or a small web page to administer your Raspberry Pi, and you can now use HTTP2 for your user interface if you're using a web application. Okay, so for the guy who has all the Raspberry Pis, how many of these do you have? Do you have a Raspberry Pi B? Okay, so you have some 2s and you have some 3s. Any older ones? No? Anyone have an original B? Or a B plus, rather? Okay, you have a B plus. Okay, does anyone have the small one, the Raspberry Pi Zero? Okay. What? Hey. A plus, A plus. Oh, okay, so the A plus is yeah, so it's about 2/3 the size of a regular Raspberry Pi, and it's much flatter as well. Oh, actually, so speaking of new stuff coming out of the Raspberry Pi Foundation, so I was in Japan, hanging out with the Raspberry Pi user group leader, and he showed me a bunch of I don't know, top secret stuff from the Raspberry Pi Foundation. But the one I thought was the coolest was they had some embedded boards which you could choose which connections you want to solder onto them. So you know how the Raspberry Pis are fairly thick because you have USB connections, you have Ethernet, you have all the ports already built in. So they had some designs where you could pick and choose which ports you wanted to attach to it and then add them on later. Okay, so for Java support, Java 8 supports all of these different ARM chips. So if you have ARM version 6, which is all the original Raspberry Pis, A, B, B+, and 0, that works with Java 8. If you have the Raspberry Pi version 7, which is the Raspberry Pi 2, and the Raspberry Pi version 8, which is Raspberry Pi 3, those also work with Java 8. ARM version 5 was never used on the Raspberry Pi, but if you use the Lego Mindstorms EV3, that has an ARM version 5 chip inside of it. And it also works with Java if you use the Lejos library. And all of the Intel boards, the Galileo, the Edison, etc., they're all supported on Java 8. For Java 9, they changed the instruction set they're compiling against to take advantage of new ARM 7 instructions. So it only works with ARM version 7 and above, so you're limited to Raspberry Pi 2s and 3s or Intel boards. If you have like a 0 or an older A, B, or B+, then you can still run Java 8 on those, but Java 9 won't work. The other thing which doesn't work on Raspberry Pis is the G1 garbage collector. It kind of works, but it's not officially supported, so you should use a synchronous garbage collector instead. Swing and AWTs work for user interfaces, but JavaFX doesn't. We stopped releasing JavaFX support sometime in the middle of Java 8. However, so I was presenting in Valladolid. I'm bad with this. It's in Spain. Yeah, Valladolid. Yeah, thank you. And I met with Jose. So he's one of the guys who is running this company, Gluon, and they have a JavaFX distribution for Android, iOS, and also Raspberry Pi. So what happened was we released all of the source code for JavaFX running on various platforms to OpenJDK, but we're not currently supporting and testing it. So Gluon's taken on creating builds from the OpenJDK repository, doing updates. Johan Voss, the founder of the company, is one of the OpenJDK contributors, and they also do releases of this, which you can download off their website. So if you go to Gluon's website, you can download the JavaFX embedded SDK. And Jose told me they're currently working on Java 9 versions of all of these. So they're going to have a Java 9, Android, iOS, and embedded SDK coming out hopefully soon. Okay, so he also gave me some flyers. So this is some shameless promotion from one user group to another. Good catch. And part of it is I also don't want to take those cards back to the US with me, so hopefully you guys will make good use of them. Gluon also creates a product called Scene Builder. So this is a GUI building tool. Again, this was something which we originally built at Oracle. It was actually the team in France who built this. And they did a really good job. It's a really slick user interface. Very nice, easy way to build user UIs. If you remember the old GUI builders like Matisse, the Swing UI builder. It would code generate rather than creating a static definition. It would code generate a bunch of stuff that you had to maintain. The way Scene Builder works is it generates an XML file, and you can edit the XML file. So you can hand edit it and give it back to Scene Builder, and Scene Builder will happily bring it up and let you drag and drop and edit it again in the Visual Builder. The only code is your controller class, which you use to integrate with this. So you hand write the controller class, that's your code. Scene Builder works with the XML file exclusively, and that way you get rid of this conflict between the GUI builder generating code or vice versa, which is very hard to maintain. So they did a good job with it if you're building UIs, such as this one, which is a coffee demo. So this coffee demo is one of the projects in the book I wrote, but this is an enhanced version we're using at the Java 1 and Oracle Code conferences. And it consists of 3 different grinders. Each of these has a relay hooked up, so it can turn them on and off. A scale, which is hooked up over serial, so it has an RS-232 converter, so it can hook it up to the Raspberry Pi serial. It has a temperature probe, and the temperature probe uses the one-wire protocol. So another noteworthy device which uses one wire is the original Java ring. So if you ever saw the Java rings, I think one year at Java 1 they gave them out to all the attendees. Those use one-wire protocol, and the reason why one-wire's used quite a bit in small devices is it can theoretically provide power and data over a single wire. So if the device at the other end supports it, the pulses for data are enough to actually give power to a device. So if it has a capacitor, it can build up enough charge that it gets power to activate itself and then respond. And then if you have the proper setup, you can get rid of grounds by having a common ground wired up some other way. In practice, it usually ends up being 3 wires though. One for power, one for data, one for ground. But theoretically, it can be a 1 wire as well. So that's what this temperature probe is. It's a small embedded device at the end of it which measures temperature and sends back data across. And then it has a couple touch screens hooked up as well. The touch screens are running a JavaFX user interface. So this is using the Gluon version of JavaFX. And since it runs on embedded and it also runs on mobile, I have a version of it on my phone, which you can see. So the UI lets you choose the coffee type and also the strength of the coffee. So you can see if you click download this QR code, you'll get the same app on your phone. It works on Android and iOS, but I have it here as well. And you choose your coffee type and your coffee strength. You click place order and it gives you back a QR code. This QR code is sent to the cloud. I'm using our Oracle Cloud with a Java EE backend as the backend for this application. And then when you scan it on one of the coffee machine setups, we wrote a program with the PyCam where it can pick up the QR code and then go and request the QR code in the cloud and get your order back. So pass this around. And feel free to give it a try. Okay, so second example, this is actually the newest demo that we worked on, is a Raspberry Pi integrated with a CNC cutter. So this guy in the background is the Carbide 3D CNC router. So it's a 3-axis CNC router which can cut out metal, plastic, and wood. So it can carve out of different material types. In this case, we're carving figures out of acrylic plastic. The reason for acrylic is it's fairly safe for use in conferences or open venues because there's no small particles or fine dust. With wood particles, sometimes people have allergies to it, so you can have problems with a conference setting. Here's the prototype in my garage, and you can see this is one of the 7-inch Raspberry Pi touchscreens hooked up to a Raspberry Pi, which is connected via USB to the CNC router. And then you can draw with your finger on the JavaFX user interface, and then it will cut something out of the CNC router that matches. So, a lot of fun to play with. And at the Java One conference, we had an artist, Miria Wellman, and she took all the designs from the attendees and then created a large collaborative sculpture out of them that was shown at the closing keynote of the conference. Oh, did it get locked? Thank you. Here you go. So this is one example of what you can do with a demo like this with CNC routers. Here's the code that attaches to the CNC router. So it just opens up a serial connection. You can see here it's opening up on dev tty acm0. Usually that's the serial port in the Raspberry Pi. Sometimes it's randomly 1 or 2 or some other number, which we found out when we had a bunch of these running at Java 1. And then the baud rate, which is, in this case, it expects 115,200. And then you can start sending commands to it. This is what G-code commands look like in their raw format. Basically, these commands are the initialization procedure for the printer, which we figured out by sniffing the network packets from or snipping the serial packets from the program that came with the printer to see exactly what the algorithm was they used to initialize it. But basically what it does is it calculates the work plane offset by moving the head over, touching this little metal detector. It's a little button. And this detects the length of the tool. When it presses it, it knows exactly where the tip of the tool is, because as you're cutting, the tool dulls, and so the height changes slightly. And then based on the height of this and the height of your work surface, you can figure out exactly how far down you have to cut when you're cutting an object. So you have the work coordinates, which are usually positive, and this is what you're cutting out. And then you have the machine coordinates, which are negative, and those are based on the homing position, and you have to calculate the offset between work and machine coordinates to get the precise location for cutting. Here's an example of some G-code commands. So G21 sets units to millimeters, G90 sets to absolute positioning mode, M3S9000 sets your spindle speed to 9,000 rotations per minute. Then this goes through and does a bunch of positioning for moving it around. And the code we wrote uses a Java 2D algorithm to calculate the exact paths to trace the shape which you created. We actually got some help from some folks on the Java 2D team to figure out how to take a single line path and then expand it to be a wider path, because we wanted to cut out two sides, an outer side and an inner side, to get a shape which was about the right thickness for the sculpture. And then it finally goes through a homing cycle and then resets the CNC router at the end. The way the commands are sent is over serial, so it's serial over USB. The printers expect this protocol called GRBL, GRBL, and we're using a library called Universal G-Code Sender to send the commands to the printer. So this is an open source library written in Java. It sends commands, queues them up, delivers them over serial, and makes sure they're the right length for the limited protocol. So with serial, you can only send lines of a certain length, and you have to do things like truncate the decimals and make sure things fit exactly. Otherwise, you overrun and you get erratic results. Okay, so same idea. This is the second app on the phone. So if you wanna try it, click the back button. So just on the top left, there's a back button. Click that, and then choose the second one in the menu for the CNC. And then you can draw a shape with your finger. It has to be a continuous line, but it can't cross itself. So it has to be like a outline type. It can't be a zigzag, which crosses itself. But anyway, same idea. You draw a figure, you can submit it, it submits the paths and stores it in the cloud. We had Raspberry Pis with Pi cameras hooked up where you could scan it and then get your image on the device, and then it would cut it out using the Raspberry Pi sending G-code commands over serial. Okay, and then the last demo is the line follower. So that's this guy, who we're hopefully gonna get working. So the line follower is made using the MakeBlock robotics set. This is a company in Hong Kong which has a bunch of different cool hobby projects, but you can basically think of it like Legos for big kids. So all of their pieces are extruded aluminum. They're very strong. They connect together with either rivets, plastic rivets, or metal screws. And the metal screws can be screwed in anywhere along these channels. So these channels are a cool design where they have little ridges in it, and you can screw in perpendicular to the ridges at any point. And they give you motors, they give you tire treads, they give you a bunch of different sensors. In addition, I hooked up a Raspberry Pi and adapted their Uno shield using this RB600 converter from Raspberry Pi to Uno. The advantage of this particular converter for my purposes is I didn't want something which had an Arduino chip on it. that you're simply talking through an Arduino chip to the sensors. I wanted to directly control the servos and the proximity sensor and the line follower bit directly from Java code. And so this is a dumb converter. It doesn't have an extra chip on it. It simply remaps the ports from Arduino ports onto the same GPIO ports which you use for Raspberry Pi. So it's the same thing as if you were wiring directly to the Raspberry Pi's GPIO. Here's some example code using the Pi4J API. So in general, all of the code is designed and uses Pi4J as the library, which is an open source library for connecting devices and sensors. Here's the line follower algorithm. Basically, it's pretty simple. So it has a left and right sensor, and if both of the sensors are white, it assumes that we're lost and it keeps going straight. If the left sensor and the right sensor both show black, then it knows it's on the line and it follows forward. If the left sensor is black and the right sensor is white, then we're off the right side, so you turn left. And if you see white black, then you're off the left, you turn right. And actually, I had an idea on how to improve this. So we'll try this version first, and then maybe we'll attempt to do some live coding and see if we can't make it slightly better. Okay, so let's give the line follower a try. So I have this guy. It's a Raspberry Pi 3, and it's hooked up. Hopefully, it's hooked up over Wi-Fi, where we can connect to it. So I'm going to open up a terminal and see if we can't get to it. Okay, so I have Bonjour set on the Raspberry Pi, so we can look it up by name, and now we're hooked up to the Raspberry Pi. Here's the JDK9 folder. And you can see that I'm running an early access version of Java 9. And I talked earlier a little bit about JShell. So usually you wouldn't use JShell on an embedded device. It's kind of silly to SSH into a device and then run JShell from it. You're more likely to do that from your desktop or somewhere else. And you can see it's not particularly fast on the Raspberry Pi either. In general, compiling and doing stuff on the Raspberry Pi directly is not the fastest in the world. But, oh, how was my spelling? Good? Yeah, okay. So you can see running simple programs very easy, doing complex stuff, not so much fun. So we're going to switch to a real IDE and do stuff in NetBeans. Does anyone use NetBeans for their development? Okay, a few folks. Any IntelliJ fans? Oh yeah, a lot. And how about Eclipse? Okay, a few as well. I interchangeably use pretty much all IDEs for Java at various points. There's a nice plugin for IntelliJ which allows you to do remote device debugging. I can't remember the name, but I have it installed and I use that occasionally. There's a plugin for Eclipse as well. NetBeans has built-in support. So in NetBeans, to run stuff remotely, all you have to do is add a platform and then choose Remote Java Edition. And then you can do your host. Let's do line pi, username, password, remote JRE path, which I always forget. But this is basically the location of your JRE, and it will actually connect to the runtime, and it will check, and it will tell you when you've made a mistake, like forgot to put local. Okay, so it's actually connecting to the Raspberry Pi, checking to make sure there's a working Java version, and adding a new JRE, and just to make sure we're actually using the one we set up, I'll switch the runtime configuration. So when you're setting this up, after you've done that, you can choose a new configuration. You have to add something new, not use the default. And then we can choose our BordeauxJUG, and then we can actually run it using our configuration we created. Okay, and it will automatically connect to the Raspberry Pi, compile the jar file, deploy the jar file to the Raspberry Pi, and then run it, which you can see happening on this bottom one. So it's running it with, oh yeah, that might not work. Hold on, that's the wrong window. So it's going to fail shortly, and I'll explain why. So, wiring Pi must be root. Did you forget to sudo? So when I set up the config, BordeauxJUG, I didn't set an exec prefix. If you want to run as root, you can add an exec prefix of sudo. And now it will run the application as root, which Py4j requires. There's another mode that doesn't require root, where you do things via the file system, but it's like 10 times slower, so don't do it. I mean, it's a small embedded device. Security for applications running on the device having root access is not that big of a deal. Okay, so same thing, we're running on it and connecting. If you guys want to get a better view of the demo here, stand up, it might be easier to see. And where are our track creators? Who created the track? Okay, so come over here and explain some of the features of the track. What's
Very advanced track. It's made for high-speed robots.
High-speed robot.
That one is perfect.
Very good.
So it's going to start over there. In this way.
Which one's the start?
I don't know which one it is. That one.
That one. Okay, and this line follower has a feature which we're going to test. So I need you to stand on the track. Yeah, just like that. That's fine. Yeah, just hang out there. Okay, so remember I said we're going to do a small improvement to the line follower? One thing I noticed when I was testing this in Viadolid was that it the black tape I'm using is thinner than my usual tape. Oops. Okay. Safety feature didn't work too well. Stand a little more forward. Yeah, because the sensor's here, so make sure your ankle's on the track. Yeah. Okay. Let's try it again. Okay. Yeah, it's working. It's just slow. So it keeps falling off the left and the right side repeatedly because the black... Okay, so it notices you're there and it stops. Step out of the way. Yeah, good. So I noticed this with the thin tape. It wiggles back and forth because it's constantly falling off the left and the right side. But I thought of a better algorithm which would prevent this from happening. So we'll see if we can update the code and make it slightly better. But you can see it's working slowly. We'd like it to work faster, I think, right? Because this is a high-speed track. It should be cruising around this. Oh, and the way the proximity sensor works is it sends out microsecond timings for the distance. So it's an analog sensor, but I'm using the Raspberry Pi digital sensors to read it. The Raspberry Pi is not particularly good at handling analog sensors because first it's running Linux, which is a non-real-time operating system, so you get random pauses from context switching. And second, you have Java running on top of it, which introduces another layer of complexity. So if you use the normal Py4j API, it doesn't work at all because it's too slow. But if you use the low-level Py4j API, which is a thin JNI veneer on top of the C library, you can actually get really close to microsecond timings. So it can reliably detect about this distance here. If it gets closer, it can't really tell the distance anymore, but farther away it can tell. Like it can tell things from, you know, about a third of a meter all the way to infinity. Okay, so let's hack the code and see if we can improve it. Okay, so the idea I had for fixing this is the oh, thanks. We draw on the whiteboard? Yeah, I guess so. Okay, so if we have a line like this, this is our black line. And we have like two sensors. So the way this works is there's a sensor on the right side and there's a sensor on the left side. And so that gives us, 2 points. So with a thick black piece of tape and two sensors which are close, you stay on the black line for a while before you slide off. With a thin piece and then the sensors are about this far apart, the challenge is you're always like one off, right? And so that's why you see him turning left and right repeatedly. But I think what you could do instead is, rather than just looking at the current state of the black and white, you could keep track of what the last time you saw it go off the tape. So for example, if you're going at this angle with the sensors, so you need to turn left, right? So currently, the moment the right one deviates off the strip, it's going to immediately turn left. But what you could do is you could delay it until this one goes off, until the left sensor goes off the strip, and that would give you a much farther run before it has to turn. Okay, so let's see if we can't actually fix this code on the fly and make it slightly better. Sorry for the egregiously large fonts, but this is my presenter fonts. Okay, so we have the left and right. So you notice if we're both black, we're fine. If one is black, if the left is black and the right is white, then we say the line location. We tell it to drive left immediately. And so my thought is, don't do that yet. But we'll just set a variable. Or let's call this last line location. So this is the last known line location. So we're just going to set a variable and say we should turn left sometime in the future. And same thing here. Don't actually turn left. And we'll just put last known line location. And then previously, when we get lost, we're not doing anything. This is when we're white, when both sensors are off. So this is when we should turn. So in this case, we do line location equals last known line location. So the moment we see two whites, then we correct by doing the last turn, which we should have if we okay. And then I think just as an edge case, if we go from black to white, I think we want to continue going forward. So we'll just, when we're on the line with both sensors, we'll always set last known line location to drive forward. And we actually need to create this variable somewhere. And we'll just arbitrarily initialize it to go forward. All right, so what do you think? Let's try it, experiment. Okay, so so it's compiling on the desktop, and then it's going to copy the finished jar file over to the Raspberry Pi. Compiling on the Raspberry Pi is just slow. Like you saw, JShell took, as long as it took me to talk over it to start up. So in general, it's much better to have like a remote computer doing the compile and deployment, and then have the Raspberry Pi just as the execution. Okay, so you can get up and let's see if it's slightly faster. Oh. Oh yeah, yeah, much better. Uh-oh. So he kind of caught back up on the track. Um, so I think what might be happening on the track is everything outside of the white line looks like black to it, right? So with an algorithm like this where we're being fairly aggressive on delaying the turn, if there's not enough white, he's going to have an error, right? Because he'll see the other black outside the track as an extra line. But it's definitely faster. Well, he might get back on. All right. All right. Well, I declare that successful enough. All right. So thanks for helping me edit the program on the fly. Okay, so this was one of the examples from the book Raspberry Pi with Java, which I wrote together with Jim Weaver. So you have the line follower. There's a coffee demo as well, using an AeroPress, but I also have a tea demo, which uses the same serial scale as in the coffee setup I showed you guys earlier. There is a Raspberry Pi Game Boy demo. So this is a 3D printed case with a folding screen like a Nintendo DS. Inside of it is a Raspberry Pi, and the Raspberry Pi runs the half NES emulator. So I did some performance tuning on the half NES emulator to get it run at about 60 frames per second on the Raspberry Pi 2. So on the 3 it should be perfect. And then this last one is a Magic Hat with an RFID card. So it is an RFID sensor inside the Magic Hat. The cards have very lightweight RFID tags inside them, which are almost invisible. And this is a good way to play magic tricks on your friends. You can, read the cards by just passing it over your hat. So hopefully you guys enjoyed the presentation. Thanks for having me at the Bordeaux Java user group, and congratulations for our track designers. You guys did a great job. Yep, so. Well, first of all, you can't run Java on Arduino. So that's a small, small problem. In general, Arduino chips are really good at doing repetitive tasks or things which require precise timings. So remember I was saying the proximity sensor, I had issues getting it working on the Raspberry Pi. With an Arduino, it's very, very easy to get microsecond timings because it's single-threaded, it runs in a continual loop. You can just get exact microsecond timings, and the chip's not very smart. It has nothing better to do than just wait for a sensor to give data back. Same thing with like controlling motors. So doing precise control of servo motors is also much easier to do with an Arduino processor. So as an example, the Carbide 3D example I showed with the CNC cutter, inside the CNC cutter there's an Arduino class processor which they use to control the 3 servos. It's very reliable. It can run the servos. It can do exactly the same procedure with precision time and time again, but it's not very smart, right? So you can't attach a touchscreen display to it. You can't do like the algorithms we were doing for drawing and calculating paths. You can't hook up like Wi-Fi networks or more advanced networks to it that easily. There's some ways to do it, but it's fairly low speed. So usually what people end up doing is they do a mix. They do some Arduino for low-level motor control and some Raspberry Pi for like cameras or displays or more complicated interactions. Okay, but good question. So the performance should be similar with Java 9. So I switched this program to Java 9, and for the stuff I'm doing, I didn't notice any significant performance difference, which I guess is good. The size will be smaller. So when you use JLink and you create a small executable, you'll get a smaller installable runtime, which is good. It's also good that you don't have to have Java installed on the device beforehand. So if you use JLink, you can just create a single executable that will run on the Raspberry Pi regardless of whether they have Java or what version of Java is installed. Yeah, so, well, I mean, in this case, I'm deploying just my class files for the project, so that's fast. But if you're deploying the entire application plus the JRE, it would be much faster, right? So, I mean, the initial setup time, copying over JRE, setting everything up, you can avoid that with JLink and simply deploy a small self-contained program. Yeah. Mm-hmm. Yeah, no. So this one, this is a gaming console. This guy. Yeah. So the original half NES implementation used Swing for rendering and Java 2D, and it was too slow. So well, first I tuned the Swing code and I fixed a bunch of issues with it because there was he had issues with multi-buffering, so he would copy to arrays and then copy those to graphics buffers, and there was a bunch of indirection, so I cleaned all that up, and then I fixed problems with in Swing if you don't have the resolution that your buffer is and the output resolution exactly synced up, then it does another copy internally. So I fixed some issues with that, and I got it as fast as I could with Swing. But the problem with Swing is it goes through, it has to go through the windowing system. So you have to run X windows, and it has to go and copy through buffers on the operating system itself. With JavaFX on embedded devices, it goes directly to the display. So it uses the 3D rendering pipeline instead. So I did exactly the same code for the UI, rewrote it in JavaFX, and used a canvas for direct output. So JavaFX has a canvas support which lets you bullet pixels directly to the screen. And that was the best performance I could get on the graphics layer after. I spent a couple weeks performance tuning this, the UI and also the Java code, to get it to run fast enough to work on, Java running on Raspberry Pi at good frame rates. Yeah, so you can make your own gaming console with a little work. Yep. Yeah, so that's a good question. So I'm actually not running JLink. I'm running a jar file. It should be in the I think it should be like in the 10 to 20 megabyte range, but I'd have to test it and see. Yep. Okay, well, thanks very much for coming to the presentations, and hopefully you'll try Java 9 on the Raspberry Pis, which some of you already have.